Okay guys, this is day 6 notes. Again, multiplying binomials. Let's do a little warm up first. All right, for the first one here, find the GCF. You guys know that is the greatest common factor. All right, so to think of it in another way, okay, we're looking at these two terms, this one and this one, to see which factors they have in common. So right off the bat, I can see that they both have a factor of 4. 4 goes into 8, 4 goes into 12, and they both have an x as well. So the GCF for this one would just be 4x. Here we're looking at these 3 terms. All right. Now this one says be careful. This one says factor. It doesn't just say find the GCF. It says factor. So step number 1 is to find that GCF. All right, and out of those 3 terms, they both have a 3. All 3 of them do, and they all have an n. So my GCF would be 3n. All right, so you're going to divide 3n out of each of those terms, and we're going to be left with 5n squared minus n plus 4. If you want to double check that, if you just went ahead and multiplied that 3n back in and distributed, you'd get your original 3 terms there, okay? All right, look at C. Simplify the product, okay, or each product. So we're going to go ahead and distribute this, all right? So we're going to have 2x squared times x, which is going to be 2x cubed. Multiply this, and we're going to get 18x squared. Okay? And I cannot add those 2 terms together because they are not alike. All right, we're going to multiply this one 3 times. So we're going to have 2 times 6 is 12. X times x cubed is x to the 4th minus 2 times 1 is 2. X times x squared is x cubed. And then 2 times 5 is 10. X times x is x squared. Now, none of those 3 terms are alike. They all have different exponents, so I cannot combine them. So there's my answer. All right, so for today's stuff, all right, is multiplying binomials. Guys, it is so important that you understand and you get good at multiplying binomials together because we're going to do that a lot, okay? All right, here we go. Remember yesterday I talked a little bit about the FOIL, first, outside, inside, last. You can use that if that helps. Otherwise, you're just taking and distributing. It's called the extended distributive property. So we're going to distribute the 6x to those 2 terms. So I get 12x squared, because 6 times 2 is 12. X times x is x squared. And then 6x times 3 is 18. Now, I'm going to distribute the negative 7. Be careful, it is a negative 7. This is going to be, all right, I'm forgetting x there. This is going to be negative 7 times 2x is negative 14x. And then negative 7 times 3 is negative 21. Remember that those 2 middle terms are alike. So this drops down, 12x squared plus 4x minus 21. That drops down. And those 2 become, okay, that 4x. And there's my answer. All right. All right, I'm going to show you guys an alternate way of doing this. All right, get the same answer, just another way of thinking about it. All right, I can make myself a little box. If you notice, I have 2 columns by 2 rows because I'm multiplying 2 binomials. So it doesn't matter. I'm going to take one binomial and put it on top, 6x. Minus 7, the 6x is in this column, the negative 7 is in this column. And then the other polynomial goes on the side, 2x goes in that row, 3 goes in that row. All right, now to fill in the box, you're going to multiply the row and the column. So multiply these two together, and I get 12x squared. If I multiply 2x times negative 7, I get negative 14x. 3 times 6x is 18x. And then 3 times negative 7 is negative 21. Now what you'll notice is on the diagonal, those are like terms. So 12x squared plus 4x minus 21. And it's the same thing. Oops, sorry. It's the same thing, okay? So you can either just use the extended distributive like we did up here, or you can use the box method to multiply. Now you can multiply binomials times binomials, binomials times trinomials. Any polynomials you can multiply together by using the same box method. All right, let's look at F. So I'm going to distribute, all right, and that's going to give me 63a squared plus 36a. I'm going to multiply that negative 8. I'm going to distribute that. So negative 56a minus 32. These two are alike. So 63a squared minus 20a minus 32. This is the product of multiplying those two together. Those are two binomials. All right. All right, let's look at, again, multiplying two binomials. We're going to multiply y plus 4 times 5y minus 8. This time, I'm going to use that box method in case you like that. I'm going to make the box. Y plus 4 goes on top. 5y minus 8 goes on the bottom. This is going to be 5y squared. If I multiply those two together, 5y times 4 is 20y. Negative 8 times y is negative 8y. And negative 8 times 4 is negative 32. Again, these two on the diagonal are like terms. So 5y squared, always start with the highest exponent. All right. Then this is going to be minus, nope, not minus, so plus 12y, and then minus 32. All right, another one, h. So I'm going to distribute this. I get 8w squared plus 40w plus 2w plus 10. Those two are alike. 8w squared, 42w plus 10. All right. Okay, and we do a lot of stuff, a lot of story problems with multiplying binomials and finding areas and things like that. So for this one right here, it says find the area of the shaded region. All right, so you guys should know, if I think about this as a whole, all right, if I'm going to find the area of the whole black rectangle, I'm going to multiply length times width, because the area equals length times width. All right? All right, so I'm going to multiply these two together. Multiply x plus 3 times x plus 2. Okay, so let's go distribute. I get x squared plus 2x. I'm going to distribute the 3x plus 6 plus 5x plus 6. Okay, so this is the area of that whole black shaded region, okay? All right, next I want to find the area of this the white cutout. Think of it as like a donut. All right, so I'm going to multiply x times x minus 3, length times width. Distribute x squared minus 3x. And that is the area of the, oops, make sure you guys can see that. That's the area of this white rectangle. All right, so what I'm going to need to do is take the whole shaded part and subtract just that little white rectangle. All right, so I'm going to take x squared plus 5x plus 6, and I'm going to subtract x squared minus 3x. And I can just stack them vertically like that. X squared minus x squared, they cancel out. 5x minus 3x is 2x plus 6. Okay, now I did make a mistake. If you guys can see where I did make a mistake. All right, when you subtract a negative, all right, that makes a positive, right? So this should be 8. So that should be 5x plus a negative and a negative make a positive. So that should be 8x plus 6. All right, good thing I caught that. All right, good deal. And then the last one, you guys, for J, I'm going to show you how to use the box. You could just use your extended distributive, distribute the x, distribute the 5. That would be fine. But you could also, if you like using the box method, all right, watch this. This time I'm going to make 3 columns because I have a trinomial. So x squared minus x and 4. And then the binomial goes on this side. So I'm going to multiply here. I get x cubed minus x squared plus 4x. 5x squared goes in this box. 5x and 20. And once again, if you notice on the diagonals here, guys, these are like terms. So I've got x cubed plus 4x squared minus x and plus 20. All right, and there's my final simplified product after multiplying those two together. All right? Okay, guys, I hope that helped you.